Hey, what's up everyone? Welcome to hok'stutoring. So today we are going to be doing a probability question which has been popping up in exams quite a lot and many students are struggling with it. So they're not struggling with it because it was hard, but it was because it wasn't covered in the textbook quite thoroughly. So let's go into this. This is question 15 from chapter 15a. It was just that last question and there was no explanation to this. So today I'll be explaining to you why there is a difference to what you normally do or what is explained in the textbook, and I'm pretty sure just by looking at this question you already know what's happening. So let's read the question first. Mikki or Mikey buys 3 bags of bananas and 2 bags of apples, so standard linear combination from the greengrocer. If bags of bananas have a mean weight of 750, so let's just call B as bananas. Mean weight, so EB, is 750 grams, and a variance, so VARB, of 25. And bags of apples has a mean weight of 1000 grams, so EA would be 1000 grams. And a variance of 50, so not E, so that would be variance of apples would be 50 grams. What are the mean and standard deviation of the total weight of her purchases? Right, so what the question is asking is, okay, what is the mean weight of her total purchases, which includes 3 bags of bananas plus 2 bags of apples? So that's what they're asking. For expected value or for mean, it's very simple. Just follow the formula. You split it out into your independent variables. So E3B plus E2A. Take 3 out, times it by EB, plus 2 times it by EA. And then just sub in your values. So in this case, 750 comes over here. That's 3 times 750 for bananas. And then that's 2 times 1000 for apples. So this is very simple. Nothing different from what the textbook explained to you. Your answer for this should be 4,250 grams. So in total, Mikki's purchases mean weight is 4,250 grams. Very simple. But here's the confusing part. Finding standard deviation of the total weight of her purchases. So traditionally, to find standard deviation, you would need to find variance first. So we're going to do that. Variance of 3B, that's her total purchases, 3 bags of bananas and 2 bags of apples. But what the textbook, what you might be thinking is, okay, I'm going to split this out into variance 3B plus variance 2A. And then I'm going to take 3 out of the variance, which would give me 9 variance B plus 4 variance A, because if I take a coefficient out of the variance, I square it as the textbook has told me, and then just do your calculation. But this is wrong in this scenario. Why is that the reason? That's because this is actually not how you set up. It's not variance of 3 bags of bananas plus 2 bags of apple, just like in this case, but you can actually use this for mean. For variance, it's a bit different here because the 3 bags of bananas are not the same bag. Okay, it's not the exact same bag. It's 3 different bags of bananas, and it's also 2 different bags of apples. So what is happening is not variance 3b plus 2a, it's actually variance b1 plus b2 plus b3. So that's bag number 1, bag number 2, bag number 3 for bananas, plus A1 plus A2. This is actually what's happening, and that's actually what's happening for expected value as well. But it's for expected value, don't worry, it's the same thing. For variance, it's actually different. So what is happening here is it's actually variance. You split it out, it's still linear combination, variance B1 plus variance B2 plus variance B3 plus variance A1 plus variance A2. The reason why you can't use this as opposed to using this is because these 3 bags of bananas and 2 bags of apples are different bags, not the same bag. I'll show you a scenario where you actually can use this later on, but for now let's stick with this first. So yes, variance bag 1 plus variance bag 2 plus variance bag 3 is the same as 3 times variance of B. It's just they're still bag of bananas, but they're different bags. So what's happening is you just can't square it. You just multiply by how many bags there are. So 3 times that variance plus 2 times variance of A. Okay? So not 9 and 4, it's just 3 and 2. So just be careful there. It's still linear combination, independent variables. The difference is there are different bags of bananas and different bags of apples, not the exact same. I'll show you a scenario, so don't worry, just wait. 3 times variance B would be 3 times 25 right here, plus 2 times variance A, that's times 50, and then your answer should be 175 grams. And of course, if you want to find the standard deviation, just square root 175, you should get your answer, okay? So that's pretty much the answer on your textbooks as well. It's just the textbook doesn't explain this. Okay, so the moment you've been waiting for, when do you use this instead? When do you use variance 3b plus variance 2a, and then you take out the coefficient and it becomes a square? So you use those. I'll improvise on this question a little bit. I will say, what is the probability? So what is the probability that, okay, the wording of the question is very important here. What is the probability that one bag of banana, so one bag of banana is twice as heavy as a bag of apple if you were to take it out, okay? So if you're gonna put apples in that one bag and you put bananas in that one bag, it's only on one bag, okay? One bag of banana, one bag of apple, but then the question is, what is the probability that one bag of bananas is twice as heavy as apples, or twice as heavy as one bag of apple, okay? So it's only talking about one bag, not two bags, unlike your previous questions, or 3 bags for bananas. It's talking about comparing one bag to the other one bag of apples, okay? So in that case, okay, so you can just move that over, just like your normal, typical linear combination questions. And then, of course, to solve for this, you need to find EB minus 2A, and you also need to find variance B minus 2a as well, right? So for normal distribution, let's just say it can be normally distributed. Okay, so expected value, same thing, do your stuff, EB minus 2EA, nothing too hard, but for variance here, this is actually when you can square your coefficients. So variance B plus variance minus 2a, split them apart, variance B, and then when you take that negative 2 out, it's actually now plus 4 variance A, okay? It's not because it's negative, it's because it's comparing one bag to the other bag. It's only on the same bag, right? So that's when you can use your square of your coefficients, okay? So that's the difference. So if they're talking about multiple bags, different bags, then you have to use this one right here, where it's just variance B1 plus variance B2 plus B3 and blah, blah, blah. But if the question is phrased where it's comparing one bag to another bag, where, you know, like twice as heavy, thrice as heavy, is thrice a word, but anyway, something like that, that's when you can use your square of your coefficient instead, okay? For variance. For expected value, it's the same for all of them, but for variance, it's actually different, okay? So that's pretty much what I wanted to conclude with this video. Hopefully it helps alleviate your issues with probability, especially for linear combinations, independent variables. But aside from that, guys, thanks for watching, and I'll see you next time.